Now, calculating the adjusted critical points. Now, the pseudo-critical temperatures and pressure of a natural gas mixture were calculated as 380 degree Fahrenheit and 675 psi A. If the CO2 content is 12% and the H2SO is 22%, calculate the adjustment factor and the adjusted values of the pseudo-critical temperatures and the pseudo-critical pressure. Using the Standing Katz compressibility chart, calculate the compressibility factor for the gas at 80 degree Fahrenheit and 1000 psi using the value of the pseudo-critical temperature and the pseudo-critical pressure calculated. Now let's begin. So the question now is, now we are given the pseudo-critical temperature to be equal to 380 degree Rankine, then the pseudo-critical pressure to be 675 psi A. Now we are asked to calculate the adjustment factor if, since the percentage of CO2 is equal to 12%, the percentage of H2S in the mixture is 22%. Now, the formula for the adjustment factor is equal to 120 times A raised to power 0.9 minus A raised to power 1.6 plus 15 times B raised to power 0.5 minus B raised to power 4.0. Now, where this symbol is the adjustment factor, and A is the summation, I can say is the sum of the mole fraction of CO2 and H2S. Now B is the mole fraction of H2S. So now from this expression, the mole fraction of, let me just say, mole fraction of CO2 is equal to 12% divided by 100, which will give us 0.12. The mole percent of H2S is equal to 22% divided by 100, which is 0.22. So now A is equal to the mole percent, the summation of the mole percent of CO2 and H2S, which is 0.12 plus 0.22. This will give us 0.34. Then B is equal to the mole percent of H2S, which is 0.22. So now, to calculate the value of this adjustable factor, which is 120 times A raised to power 0.9 minus A raised to power 1.6 plus 15 times B raised to power 0.5 minus b raised to power 4.0. So now let's now calculate. You now have 120 times a is 0.34 raised to power 0.9 minus 0.34 raised to power 1.6 plus 15 times b, which is 0.22 raised to power 0.5 minus b, which is 0.22 raised to power 4.0. So we now have 120 times. Now let's calculate this here. Now you have 0.34 raised to power 0.9. So this will give us what? Gives us this. So let me write them. So we have 0.3787 minus. Now let's calculate this. Let's see what it will give us. Now 0.34 raised to power 1.6. So this will give us 0.1780 plus this is 15 times. Now what I will do, I will just calculate all together. So now just calculate all together instead of doing it separately. So I will say 0.22 raised to power 0.5 minus 0.22 raised to power 4.0 is equal to, this is 0.4667. 0.4667. This is 0.4667. So now we have 120 times. Now if you subtract this from this, you have 0. This is 7. This is 80. This is 70. This is 3 minus this is 2. So plus now 15 times 0.4667. So now let's calculate this now. Let me see. So we have 120 times so we have 120 times 0.2007 plus 15 times 0.4667. So what's the answer? 31.08. So the answer here is 31.08. So we have 31.08 degree Rankine. So that is what we have now. Now we are going to use this value to calculate the adjusted pseudo-critical temperature. So now the adjusted pseudo-critical temperature is equal to the pseudo-critical temperature minus the adjustment factor. So now the pseudo-critical temperature is 380 minus the adjustment factor, which is 31.08. Now let's subtract and see what it will give us now. So now we see plus 380. So we have 349.92. So we have 349. Is it 348? Sorry, 348.92 degree Rankine. So now we have gotten this. Then now we are looking for this value now, where, let me just write it here, where from this formula, where TP in this is pseudo-critical, the adjusted pseudo-critical temperature. So the adjusted pseudo-critical temperature, while this is the pseudo-critical temperature. Now, so we have calculated the adjusted pseudo-critical temperature. So now let's calculate the adjusted pseudo-critical pressure. So now this adjusted pseudo-critical pressure is the pseudo-critical pressure times the adjusted pseudo-critical temperature divided by pseudo-critical temperature plus B bracket open 1 minus B times the adjustment factor. So now we have our pseudo-critical pressure to be 675 times the adjusted pseudo-critical temperature to be 348.92 divided by the pseudo-critical temperature, which is 380, plus B, which is 0.22 bracket open 1 minus 0.22 bracket close times the adjustment factor, which is 31.08. So let's write this in another place. So the adjusted pseudo-critical pressure is equal to let me just write the value, 675 times 348.92 divided by 380 plus 0.22 times 1 minus 0.22 times 31.08. So that is it. Now let's use our calculator to calculate it. Calculate the value. So this is our calculator. This is our calculator now. So we have 675 times 348.92 divided by divide by now bracket. Sorry, let me delete one of the brackets. Let me delete this, so it's one bracket. Let me start afresh. Let's start afresh. So now we have 675 times 348.92 divide by brackets. Now we have 380 plus 0.22 times, you have another bracket open, 1 minus 0.22, you now close the brackets, times 31.08, and bracket close. So that is it. Then now let's say equal to, so our final answer is 611.21. So the final answer is 611.21 psi A. So this is our final answer for. So now we have calculated the adjusted pseudo-critical temperature. Now from the question, we're asked to calculate the compressibility factor. Also, we're asked, let's go back to the question again. Now we're asked to calculate the compressibility factor at the condition where the temperature is 80 degrees Fahrenheit and the pressure is 1000 psi G. Now let's go back to the problem, to where we just calculated the adjusted pseudo-critical pressure. So we have this. So since we are calculating the compressibility factor Z, which is unknown, at the temperature 80 degrees Fahrenheit and pressure 1000 psi G, so we need to calculate the reducing temperature and the reducing pressure. So now for us to do that, we also need to convert this temperature to absolute and the pressure to absolute. So now we are going to use a base pressure of 14.7 psi A. Now, so the temperature, we need to convert it to Rankine, which is 80 plus 460. So this will give us, this is 540 degree Rankine. 540 degree Rankine, then the pressure is the gauge pressure plus the base pressure, which is 14.7. So all together will give you 114.7 psi A. So now we have gotten the pressure, we have gotten the condition at absolute temperature and pressure, which is 1014.7 psi A, and 540 degree Rankine. So now we need to calculate the reducing temperature, which is the temperature divided by the pseudo-critical temperature. So what we're going to use here now is the adjusted pseudo-critical temperature. So now we have 540 divided by 348.92. Now let's use our calculator. We have 80 plus 416 divided by 348.92. So we have 1.55. So we have 1.55 in two decimal place. So we have 1.55. That's our value. And then the reducing pressure will be the pressure, the conditional pressure, the pressure of the gas divided by the adjusted pseudo-critical pressure, which is, now let's say we have 1014.7 divided by the adjusted pseudo-critical pressure is 611.21. So now let's use our calculator to now calculate. We now have 1014.7 divided by 611.21 equal to 1.66. So now we have gotten our pseudo-critical, our reduced pressure and our reduced temperature. So these are the values. Now these are the, since we have gotten the reduced temperature and the reduced pressure, which is 1.55, and this is 1.66. So this is roughly 1.7. This is 1.6. Now let's look at the charts to get the value we are looking for. Now, when you look at this chart now, the pseudo reduced pressure is here up here, while the pseudo reduced temperature is this. Now we have the pseudo reduced temperature to be 1.7, so 1.6, which is this curve, and we have our pseudo reduced pressure to be 1.7. So this is 1.5, this is 1.6, 1.7, this is 1.7, come down to 1.6. So this is where 1.7 and 1.6 mix. So we now move down to this place. So we have roughly 0.875 as our answer. So that means our compressibility factor is 0.875. So approximately 0.875. So that is your final answer. Thank you for watching. Have a nice day. Do wait to subscribe to my channel and hit the notification bell, so anytime I do new video, you'll be the first to watch. Thank you and God bless.